Hello, this is Thomas, and I can show you how to go from your raw data from the observatory or, the data you get from online, um, straight to some nice looking light curves. So first we want to pre-process the images. So for mine, I'm looking at, my folder is named 1222. That's the date where I got this data from the 24-inch kilo telescope at the Allegheny Observatory. The object I'm looking at is PG 04 plus 761. It's a distant quasar, about a billion light years away, but it doesn't really matter for the tutorial. So we're just gonna open one of them. Make sure you have AstroImageJ downloaded. If you don't, just Google it. It's pretty straightforward, and I'm doing this on Mac. So just click on a random file, essentially, in your directory, and you want to click this DP option. Make sure you're not looking for the DP in this row. Look for it in this AstroImageJ header row. And you click on here, and boom, the CCD data processor should pop up. So I'm gonna go through this rather quickly. If you want a more detailed instruction, you can feel free to look at some other stuff I've linked in the bio, which we have a video and a document that documents this process pretty well. So yeah, so you want to be in the right directory. I am in the right directory. I basically selected this folder. I make sure that the file name pattern matches all the files I have in here. So I see that first I want to go through the red band images, which is 65. Boom, 65 does match. And then bias, I want to use my 9 bias frames, 9, so matches. Dark frames, 5 matches. Flat, so for the red band images, I want to use the red flat. So boom, that also matches. And then make sure the settings you have on the left side and everything here matches what I have. And then I'm going to use a subdirectory called red to output images, and then we can click start. So this will give us, it will basically process the images on its own, and then yeah, you can kind of see it here, but it's going to go through the entire red band, and then I'm going to do the exact same thing for the green band images, just changing the file name pattern here to G, and then the flat file here to G. So you can see here is where the program AstroImageJ is outputting these calibrated files into this directory called red, which is what I made it, what I named it. And then I'm going to do the exact same for green, and then I'll come back when they're both done. After about 3 minutes of wait, we have successfully processed all of 65 of the files, both in green, shown in this directory, and red in this directory. So for simplicity, I'm gonna first close all these windows. Doesn't really matter here. And then, so I'm still in this directory. I like to drag my process files, oops, not that one, my process folders out to the desktop or, wherever you like, just for simplicity. Yeah, so we basically don't need any of these anymore, so I'm going to close that folder, put it to the side. And next step is we're going to align each of these two stacks. So first we have to make a stack. Let's go into the green one. So boom, these are all of our processed green band files. So open it up, and we want to go to File, Open Image Sequence in New Window. By the way, this is very critical. If you click on this and you do File, there's no, File Open. And as you can see, this is different. So you want to make sure you click on the Image tab instead of the Header tab. Image tab, File, Open Image Sequence in New Window. Boom. And then, so Directory, this is critical. So you want to make sure that you want to click Browse here, and you want to make sure you're in the right directory. So we're doing the green one, so click on the green folder, and then open here. And then filter doesn't matter, since in our folder, the entirety of the folder is the quasar image in green. So we don't have to worry. It selects 65 of them, so that's all the things in the folder. Start, step 1, scale 100. Make sure you use virtual stacks. This is pretty important here. And then we want to go OK. After you have your stack here, as indicated by this 1 out of 65, you want to, click on it, make sure you're selecting it, and then you want to go process and align stack using WCS or aperture. Make sure all of your settings match mine here. And for these three are the important part because, so essentially after this process, you're gonna get something that looks like this. You're gonna have 3 rings, and you're basically using this to select 3 or 4 comparison, 3 or 4 stars that are pretty bright, and they will essentially align the stack on its own. So these 3 numbers dictate how long the radius is for each ring. So the first number is first ring, second number, second ring, radius, and so on. So yeah, let's get that out of the way. Just kind of arbitrarily, I would say these, for comparison stars, you want them, or reference stars, you want them to be fairly, you want the aperture's radius to be fairly large. So yeah, let's go with that and click OK. And then let's go back here. Let's find 3 stars. By the way, to zoom in and zoom out, you do subtraction sign and plus sign, or minus sign, plus sign on your keyboard. So let's find some pretty bright stars. This one looks pretty bright. Does it fit? It's good enough. I like to do like 3. I think 3 is good enough. Let's do this one here. It's pretty good. Okay. Then another one. Let's do this. No, that's a little too small. Honestly, that's like the biggest one I have, so just go with this. Okay, great. And then let's zoom out to see where I place them. And then now you have to do is click return or enter. And then hopefully it will go through, as you can see here, it's going through the entire stack and aligning them in the desired fashion. And then we're going to do the exact same thing for the other stack, the red stack. And then I'll come back when these are both done. Aligned, if you get this message, you have aligned your stacks. So let's exit out of AstroImageJ. And if we look at your green and red filters, make sure you did what I just mentioned for both of them. So now you should see a line folder in green and also a align folder in red. So just for sake of simplicity, let's, oh, by the way, so this is, I just dragged this out of red, so change this to red, aligned. This kind of doesn't matter, it's just personal preference. And then green, aligned. And then now you have these folders, these are done. These are your new folders. So next step is where we actually make the light curve. So let's start with one of them. Let's just start with red this time. You, again, click on a random file, and then you want to make the stack again. This is exactly the same process as stacking for the alignment. You want to select the correct directory, red aligned. This is all the same, virtual stack, 65 images, okay. And then close this, doesn't matter. This, you get a 65 images stack. And then now you want to look for your object. Okay, so specifically I use this website, simbad.cds. So essentially this is the website you want to use. Yeah, you can kind of Google it to find it, Simbad CD. And then it's just the first thing that comes up basically. And then you can essentially search up, you can do a basic search to search up the object you want. So for me, mine is PG0804, it's a quasar, and this is the finding chart essentially. So let's look at this here and look at our image. Let's compare them. So to me, it's fairly obvious that in this case, you see these 3 here in a row. So I have boom, 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 these 3, and then this one here, and then the quasar seems like it's going to be this one, right? So in this case, I found it fairly easily, but in some cases, there's something you have to keep in mind is I do have invert wide on. So I believe that for the Kilo telescope, most of the time it tends to have the images captured, the raw images tend to be inverted in the y direction. So you have to go to, make sure you're clicking on this. You have to go to view, invert y to make sure that, the y-axis direction actually matches with the conventional one that is kind of shown on these, finding chart websites here. So anyways, it's going to be this object. So now what we're going to do is, now we know what we're looking for. We want to do this. We want to start the multi-aperture alignment process. So click on this, same thing, and then we want to go analyze and multi-aperture. And then settings wise, we want to first slice, last slice, these are the same. Fix apertures, place new apertures, blah, blah, blah. Don't use auto comparison stars, I would say, because we want to place them manually. And then, yeah, leave these. Yeah, these are all fine. Send joint apertures. I'm just double checking. So yeah, make sure your settings look like this. And then this is, again, we're selecting the radius. So this is pretty important. As you can see here, the quasar is not very big. So by kind of guessing, just, you know, check and checking multiple times, you can see, you can try out different things. These three are essentially the only things you want to change. I determined my quasar kind of fits with a 4A12 radii, so I can show you what that looks like. So if I just click place apertures, you can see that kind of fits quite well on this small object. So this is kind of what you want. Just mess around with the different radius settings, and then try to place it on your object, see if it wraps it around your object, and if it does, great. If it doesn't, then go back and change it. So let's, you know, make sure it's on there. Okay, great. And then so for multi-aperture, you want to find your target. So as you can see, it says T1. And then I like to do also 3 comparison stars. This is pretty optional, depends on what kind of research you're doing. If you want to do differential photometry, which is you want to kind of see, you know, the brightness of the target object compared to its comparison stars in the background, then this is what you should do. But anyways, you can try to find 3 comparison stars that are just, you know, lying around here. Let's go for a few of them here. Oh, this might be too faint. Actually, this is fine. I think that was actually one of the known target standard, you know, non-variable stars. So these are things you should look into when you're doing research. But let's do these 3. And then you, for comparison stars, you kind of want them to be around. You want them to be around the object. So let's do another one. These are all rather faint, so I'm a little worried. Maybe. No. Let's see. I haven't done this in a while. I forgot which ones that we usually choose, but maybe. Yeah, for the sake of this video, I'm just gonna pick this one, but it doesn't matter too much. Okay. And then we're gonna click return key once again, and a bunch of windows will pop up. Don't worry, we kind of, for the purpose of this video, we only care about essentially one of them. So we want to find this one called plot of measurements. Then, you know, click on it, make sure it's visible, and then boom, basically your program will essentially track the brightness variation of the object and the comparison stars you've selected by itself. So if we want to also check box these 4 is essentially, you know, because we selected 4 things. So if you check box 4 of them here in plotting, then all 4 of them will show here. So this shows T1 is the brightness of our quasar. So as you can see here, it did not fluctuate that much over this night. So that is pretty, you know, concerning. Let's just make sure I did pick the right object again. So yeah, no, that seems to be the right one. Yeah, so it just, you know, didn't fluctuate very much, but that's just what happens sometimes. And you see the title here is actually wrong. I can go back, and one of the tabs, if you find them, one of the tabs allows you to change the label. So I can do subtitle. So this was actually you know, 1222. So let's change this to 1222, and then yeah, so this is the plot you want to look for. And then you can do this, the exact same thing in the green filter. It's exactly the same process. And then you get another graph of your object in another filter, and then these are the graphs you're looking for. And then if you don't want to see, again, if you don't want to see the comparison stars, then just click them off here, and then they're gone. And then this, you can, if you want to save them, PNG, PDF, I usually like doing PDF, so just click on that, measurements, or name it, you can name it whatever, and then save to desktop, and then it will be in your desktop as a PDF file. So that's all I have today. Thank you for tuning in, and good luck.